Hi, I'm Ganesh. I'm an engineer with the Cohesity's file system team. I want to talk about SpanFS, Cohesity's file system. If you look at data across all the enterprises, IDC estimates there's about 6 zettabytes of data in 2016. And this data is rapidly growing. It's going to grow to 93 zettabytes by 2025. If you look at the enterprise data, only 20% of it can be classified as primary, which is the data that requires strict SLAs. And 80% of the data is secondary data, things like backup, test and dev, analytics, data that needs to be archived, and so on. SpanFS is specifically designed to address the 80% of the storage that's largely ignored. Let me briefly talk about how storage evolved in the enterprise and cloud world before talking about SpanFS. In the enterprise storage stack, it is designed around reliable hardware. If you look at things like a RAID controller, if a disk fails, another disk will take over. You have redundant hardware to make sure that it doesn't fail. And the protocols that evolved also evolved around this hardware, protocols like NFS and SMB. Enterprise storage also has a lot of features. It has simple UI to make it very usable, and it has a lot of integrations. But it's expensive because it's based on proprietary hardware. If you look at storage in the cloud world, it's based on commodity hardware and it's web scale, it's scale out. But in the cloud world, they develop their own protocols. They don't use NFS or SMB. They've developed their own protocols, and it's mostly designed for like the Googles of the world. In SpanFS, we took the advantages of both the enterprise and the cloud stack and we merged them. It is scale out and it's web scale. There's no single point of failure or bottleneck. And it's based on commodity hardware, but it also implements the features in the enterprise stack, such as it provides standard protocols like NFS, SMB, and S3. It is enterprise ready, it has all the integrations, and it has a nice UI. And it also integrates with the cloud. Merging these two stacks has its challenges. For example, a protocol like SMB is session-oriented, and it has concepts like file or byte locking. When implementing it in a scale-out way, you can have a client that connects to a node in the cluster, and it can lock a file or a range in a file. And now when another client connects to another node in the cluster, and it tries to lock the same file or the range, it needs to know that it's already being locked. To solve these challenges, we implemented the protocols from scratch in a scale-out way in SpanFS. Let's look at the SpanFS architecture in detail. SpanFS is a distributed file system, and each of the components runs on all the nodes in the cluster. At the very top, you have the protocol handlers for NFS, SMB, S3, and you have data protect, which is the integrated data protection for all the common hypervisors, database, and so on. Then you have the metadata store, which stores all the metadata for the file system. This is built on top of SnapTree, which is a distributed B+ tree. This is a B+ tree where each of the node is in a NoSQL store, which is distributed. Because the metadata store is built on top of a B+ tree, the entire file system or any file can be cloned instantly. You have the I/O engine, which deals with all the I/Os that are coming in. When an I/O comes in, the I/O engine tags the I/O as sequential or random and so on, and it applies policies. Based on the policy, it decides where the I/O should land, whether it should go to SSD, HDD, or to the cloud. SpanFS has very fine-grained QoS, and whenever an I/O comes in, the QoS decides which I/Os are more important, and the important I/Os are always prioritized over the lesser important ones. Because of this, the QoS is applied at each of the layers before accessing any resource. And this provides fine-grained QoS. The entire SpanFS communicates to the cloud to do archival and tiering. And SpanFS can also talk to other SpanFS clusters in remote sites to do replication. SpanFS is a distributed scale-out file system, and it has been built from scratch to handle the secondary storage needs. It provides instant cloning because of the B+ tree, and it has other enterprise features such as snapshots, deduplication, and so on. Because of this, it can consolidate backups, file services, test and dev, archival, and analytics.